Grayfriars. Today we are on week 12 science. We've already discussed throughout the semester that science is the process of observing things and how they change, and then asking questions and figuring out ways to test things so that we can find answers to those questions, right? When we observe things and when we observe things closely and notice differences, we need to be able to identify how the thing has changed, right? And that involves measurement. So it's very important for scientists to know how to do math and understand the concept of measuring things. They have to be able to understand numbers and units of measurement. Have you guys studied any of that? What are some of the units of measurement you've learned so far this year? I'm gonna pull up your math sheet from your memory work. Like week 11, 12 inches equals 1 foot. So a foot means 12 inches. A yard means 3 feet or 36 inches. Please don't take that, Holly. Okay, we're in the middle of recording. Throughout the year, you're going to learn lots of measurements, right? So far, we've studied feet, inches, yards. If you like doing baking, maybe you've used cups or ounces or quarts. For our purposes, this semester, we've been studying chemistry. Do you remember what is chemistry? Holly, do you remember what is chemistry?
Chemistry is
the study of
matter
and how
it changes.
Yes. What is chemistry? Chemistry is the study of matter and how it changes. How do we measure changes in matter? Have you thought about that? We talked about how all matter is made up of atoms. Do you remember what makes up an atom? Holly, do you remember what particles are in an atom? Protons,
neutrons,
and electrons. Protons, neutrons, and electrons. As we study the periodic table of elements and chemical bonds, we talked about protons, how protons and neutrons are heavy and electrons are light, but the electron shell takes up most of the space in an atom. Mr. Campbell actually told me when he studied chemistry, he lived in Dallas and they had a huge sports dome, I think where the Cowboys play. And he said, if the entire stadium were an atom and you put a dime on the floor, the dime would be about the size of the equivalent of a nucleus in relation to how much space is taken up by the electron shells. Kind of amazing. I don't know that that's precise, but it gives you an idea. But an atom is super, super small. Do you remember what we used to talk about how small an atom is? So an atom is incredibly small, and what we said was you can fit 1 million atoms in the width of one human hair. 1 million atoms. So how do we even begin to measure atoms or changes in atoms? That is where our memory work for today comes in. Today's memory work says, what is Avogadro's number? The number in a mole. 6.02 times 10 to the 23rd equals 1 mole. You can also say 1 mole equals 602 hexillion. So what is Avogadro's number? The number in a mole. 6.022 times 10 to the 23rd equals 1 mole. Or you can say 602 hexillion equals 1 mole. So what we're going to say it to a song. Avogadro's number is the number in a mole. 602 hexillion equals 1 mole. 6.022 times 10 to the 23rd. You guys can practice it at home and see if you can remember that. It sounds confusing, doesn't it? What is a hexillion? Let's start out by looking at this number, okay? I'm gonna try writing out for you. If I write a 6 with 3 zeros after it, what number is that? Holly, what number is this?
600.
6,000, right? What if I delete the 6 and I add 3 more zeros? Now I have 6 million, right? And what if I keep doing that? I take away the 6 and I add 3 more zeros. Now I have 6 billion, right? What we have for Avogadro's number, we're going to have, we have 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Let me see. Let me make sure my math is right here. 6.022. Okay, let me check this. This is Avogadro's number. So we had thousands, we had millions, we have billions. We keep going until we have 20. We have, well, let's get rid of this just for the sake of ease. 23 zeros, okay? 23 zeros here. So we have 23 zeros. Watch, we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Ooh, you know what? I screwed this one up. Let me see. I'm going to do this. 23. So 6.02. 23. Okay? Another, that's Avogadro's number. A shorter way of writing this is we can write 6.02 times 10 to the 23rd. This is called scientific notation. Instead of having to write all those zeros, I know that I move my decimal point 23 times backwards to make this number. That's a lot easier, right? Than having to say 602,000,000,000,000,000,000. That would be very confusing. That's a huge number. How huge do you think this number is? Okay. Let's talk about numbers. Okay. A mole, let's first get into the concept of a mole just represents this particular number. In the same way that when I say a dozen, what does a dozen mean, Holly? If I have a dozen eggs, how many eggs do I have?
12.
12 eggs. If I have a dozen donuts, how many donuts do I have? 12. If I have a pair of socks, look at how cute these socks are, hippo socks. How many socks do I have? 2. So a pair means 2. A dozen means 12. If I have a ream of paper, it will always mean 500, right? Same thing when you talk about like bushels and pecks, those kinds of things. A mole just means this particular number. Just like a dozen means 12, a mole always means 6.02 times 10 to the 23rd. If I had a mole of donuts, right? So Holly, would you mind, I'm gonna grab this paper towel and I started stacking my mole of donuts, okay?
I think the thing.
Do you know how many donuts that would be? How many donuts do you think a mole of donuts is?
1, 2, 3, 4, 5.
If we had 6.02 times 10 to the 23rd worth of donuts, we would not only reach the sun, our stack of donuts would reach the sun and back to Earth 200 billion times. That's a huge number. Let's say if I had a mole of peanut M&Ms, man, I love M&Ms. Do you want a mole worth of peanut M&Ms? You know how many peanut M&Ms that would be, Holly? Don't steal my M&Ms. Nope, my M&Ms. Don't steal my M&Ms. If I had a mole worth of peanut M&Ms, it would fill up the entire Earth. Another way of saying, hold on, you need to go sit down. I'm filming my video, remember? So if I had a mole worth of marbles, it would not only cover the surface of the earth, it would cover the surface of the earth and go out 3.5 kilometers. So a mole is a huge number. Why is it useful to us to understand the idea of a mole for chemistry? So a mole just means 602 hexillion things. You can have a mole of anything, but generally you're not going to have a mole of peanut M&Ms, because who wants to carry around a whole earth worth of peanut M&Ms? What does a mole worth of water look like? I'm going to have my helper get something for me. Holly, can you grab a tablespoon? Go grab our thing of measuring spoons over there. Okay. A mole worth of water molecules. So 602 hexillion. This many water molecules. How big do you think that is? Holly's going to bring me a tablespoon. So this is the big spoon. Yep, bring it on over. There we go. Thank you, assistant. Thank you. Okay, I'm going to show you. How many times do you think I have to measure this to have 602 hexillion water molecules? That's it. There's 602 hexillion water molecules in this one tablespoon. So it's useful to have an understanding of this number because atoms are so small that it's hard to compare them. Whereas we can talk about 1 mole worth of water and its properties and compare it to 1 mole of another atom or molecule and its properties. We can talk about the volume of 1 mole. So that's actually how this all started out, was that a guy named Amadeo Avogadro. So the number, this special particular number, just like a dozen or 500, this particular number is called Avogadro's number, or Avogadro's constant. Amadeo Avogadro was born just a month before the signing of the Declaration of Independence. What year was that? Do you remember? July 4th, 1776. Very good. So he was born in June. And he was one of the founding scientists in the study of physical chemistry. But he was actually a lawyer who became interested in math and physics. He actually became a physics professor, not a chemistry professor. But in 1809, generally all scientists knew. Remember how science is the process of discovering truth, right? And asking questions, trying to find out answers. They understood that all gases, when heated equally, expand by the same amount. What Avogadro did that was different was he figured out that if there are 2 equal volumes of gas at the same temperature and pressure, they would contain the same number of particles, whether atoms or molecules. 2 volumes of gas at the same temperature under the same pressure would have the same number of atoms or molecules, right? So I could have 1 jar of oxygen and 1 jar of nitrogen, and he hypothesized that they would have the same number of atoms if they were at the same temperature and same pressure. Have we studied temperature and pressure at all? Do you guys remember our discussion from last week? So do you remember Charles's law? Yeah, it was on the up and up. As temperature increases, volume increases. And then as volume increases, pressure decreases. So all of this ties together, right? And then do you remember, another thing is why this number is useful. When we're talking about volume, do you remember what is density and mass? Mass is the amount of matter an object contains, and then density is mass over volume. All these concepts you guys are learning are starting to tie together. It becomes way more interesting as you get to higher levels of science. Right now, you're in 3rd, 4th, and 5th grade. You don't have to worry about all of the higher level stuff, but understanding that knowing these numbers, knowing the units of measurement will make it easier for you to discover really cool things when you get to high school or college level science, right? So Avogadro came up with this law that he published in 1811. Do you think everyone said, oh yeah, we totally agree with you, same number of particles? No, it took about 40 or 50 years until people generally accepted it, but they still didn't know how to prove it. Over time, so then in 1865, the first guy to actually estimate the number of particles was in Austria. His name is Schmidt. And then the term Avogadro's number was first used in 1909. So by a guy from France who was a physicist. So that was 100 years after Avogadro first came up with that hypothesis. Think of science as this, not just a discovering of answers. You ask a question, find an answer that opens up a whole new world of questions to ask. Isn't that amazing?
You ask why.
Yes, you ask why. And then once you discover one thing, someone else may say, but why is that? It took 100 years before they started getting closer to this number of 6.02 times 10 to the 23rd. Will you stay over here, Holly? So when you learn about Faraday and the electricity, that ties in with this. They were figuring out the charge on a mole of electrons. How do you measure that? It's so tiny. You guys, this is amazing stuff that by being able to quantify it, we can make a whole new world of discoveries. So this is kind of what makes science very fun. It can also make it challenging or discouraging at times, right? Do any of you get discouraged by saying, this is way too much information and I am so overwhelmed and I have no clue what Mrs. Campbell is talking about? Sometimes. Hopefully, at least you'll file away some of this. You now know a mole is 602 hexillion, and you're one step closer to discovering a whole new world of science. Just to let you know, you can practice this. I'll put some stuff on the website. There's a great book called about really big numbers. It talks about how our understanding of numbers can be used as it gets more and more advanced. I hope you guys have a great week, and go eat some jelly beans or M&Ms or some donuts on me. Hey, these are my M&Ms. Love you guys. Bye.
Bye, fifth graders.